Okay, so in this lesson, we're going to talk about part 2 of the introduction to polynomials. In this case, we're going to discuss how to determine the degree of a term and the degree of a polynomial. All right, so let's talk about the degree of a term first. So every term has a degree. So every term of a polynomial has a degree. All right, so let's talk about how to find the degree of a term. So the degree of a term in one variable. Okay, so in our first part, we're going to talk about just a variable, just a polynomial with a variable x. And so the degree of a term in one variable is the exponent on the variable. That's all it is. It's just whatever the exponent is. Okay, so for example, let's find the degree of each term. And so notice that there's just one variable. Okay, so based on the definition, the degree of a term is just the exponent on the variable. So this term here is 6x to the fourth. And remember, we're talking about polynomials. So the term of a polynomial, remember, has this form. It has the form ax to the n power, where n, remember, is a whole number. So we are talking about terms of a polynomial, and that's where we discuss the word degree. Okay, the degree. All right, so this is form of a term of a polynomial. That's what this is. So a into the n power, where n is a whole number and a is any real number. So if the variable, if the exponent is 4, then the degree is 4. So the degree of that term is 4. The next one. All right, negative 2x. All right, so remember, the degree of a term is just the exponent of the variable, and there's just one variable here, so it's just the exponent of the variable. And so remember, if there's no exponent, if you don't see the exponent, it's understood to be a 1, so that's a 1 here. Okay, over here, now notice there's no variable here, but remember in a previous lesson we talked about this. We talked about the fact that 4 is the same thing as saying 4x to the 0 power. So you got to remember this fact that that's constant. A constant I can write as 4x to the 0 power. And so now, if you look at the exponent is 0. So the degree of a constant is 0. That's important. The degree of a constant term is 0. And so that's why, because you can write a constant as that constant times the variable raised to the 0 power, because remember, x raised to the 0 power, that 0 property rule, the 0 exponent rule, is 1. 1 times 4 is 4. Okay, now, this was a term, so we talked about finding the degree of a term. So the degree of a term is just the exponent of that variable. Now, every polynomial has a degree. So remember, a polynomial is a finite set of terms. So it can have one term, it can have two terms, it can have three terms, and so on. So for example, if a polynomial has just one term, then we can easily find the degree. The degree is just the exponent of the variable. Now, we are talking about a polynomial with just a variable x for right now. So all our variables just x. There's no y's, no multiple variables at all in it. Okay, it's just a variable x. So if a polynomial has multiple terms, then how do we determine the degree? Do we add up all the degrees? What do we do? So the answer to that question was no, we don't add up all degrees. So you can see what the definition says. So each polynomial has a degree. So the degree of a polynomial is the greatest degree. So the greatest one, the largest one of any term of the polynomial. So you look at all the terms, you look at all the degrees, and the degree that's the largest is the degree of the polynomial. That's all it is. So the degree of a polynomial is the greatest degree of any of the terms. So you don't add up all the degrees. Okay, that's incorrect. You look at which one's the largest. What degree is the largest, and that's your degree of the polynomial. All right, so let's look at this example. So example 2, let's find the degree of each polynomial. All right, so listen carefully. What you want to do is find the degree of each term first. So the degree of this term, negative 3t squared. Now notice I'm reviewing some information from previous lessons. I'm discussing what the terms are, so it's important that you do that as well. So the first term is negative 3 squared. The degree of that term, since it's just one variable, is 2. So I'm going to write the degree here, so that's 2. The next term is a positive 7t. Now remember, that's 7t to the first power, so the degree here is 1. The next term is a constant, negative 5. So negative 5 is your constant, not 5, negative 5. Negative 5 is a constant, but regardless, it's a constant term, and the degree of a constant term is 0. And so you look at all the degrees, 2, 1, 0. The largest one listed here is 2. So the degree of that polynomial is 2. All right, so let's look at the next polynomial, 8x minus 4. So again, the first term listed is 8x. And remember, that's 8x to the first power, so the degree here is 1. The constant is negative 4. The degree of a constant is 0. My degrees of the terms are 1, 0. The largest is 1, so the degree of this polynomial is 1. So again, the degree of a polynomial, you got to look at each term, state the degree of each term, and then pick the one that's the largest. Pick the number that's the largest degree. Okay, over here, we have quite a few terms here. So this term is 2x, the degree is 1, 2x to the first power. There's no exponent there, so it's going to be 1. Here, the term is negative 7x to the fifth, not 7x to the fifth, negative 7x to the fifth. The exponent is 5, so the degree is 5 for this term. Over here, the term, positive 2x to the sixth, the degree is 6. Here, positive 5x squared, the degree is 2. Here, it's a constant term, the degree is 0, and so the largest of all of these is 6. All right, now one thing I got to mention, I'm going to put this as a D. Suppose we had 5, well, I'm going to do this in the next section, sorry. So we're done with this, so that's A, B, and C. Okay, so the degree of a polynomial, notice it's all the same exponents. I'm sorry, all the same variables. X's, X's, T's. All right, so degree is 6, the largest of all these. Okay, now, when we discussed this example 1 and example 2, there was only one variable. Okay, so now we're going to look at polynomials or terms that have more than one variable. Okay, so remember, a term can contain more than one variable. That was the definition of a term. A term is a product of a factor, a numerical factor, and one or more variables to exponents. So let's determine how to find the degree of a term with more than one variable. It's not very difficult. It's very easy to do. All you do is this. So the degree of a term with more than one variable is the sum of all the exponents of the variables. That's all it is. You just add up all the exponents for the variables. All right, so watch how simple this is. Let's find the degree of each term. All right, so we have 7x. There's only one variable there. The exponent is 1, so the degree is 1. You could have done that from a previous example. All right, now look at this. We have negative 2x squared y to the fifth. I have two variables. So according to the definition, I've got to add up all of the exponents. So this exponent is 2, this exponent is 5. 5 plus 2 is 7, so degree is 7. Okay, here, 8x cubed y. This exponent is 3, this exponent is 1. 3 plus 1 is 4. So remember, 8x cubed y to the first. So you got to add up these exponents. Over here, I have 2x to the first, y squared, z to the first. All right, so add up all the exponents. 1 plus 2 plus 1 is 4. Over here, I have x cubed, y to the fifth, z squared. According to the definition, I add up all the exponents. 3 plus 5 plus 2 is 10. Okay, now remember this. Negative 6, there's no variable there, so you got to remember this is a constant. This is a constant. So you got to remember that. There's no variable there, so it's going to be a constant, and so the degree of a constant is 0. All right, so that's how to find the degree of a term where you have more than one variable, like B through E. A and F you could have done from the previous example. B through E have different variables. Okay, so now let's talk about the degree of a polynomial that has several variables. So a while ago we talked about the degree of a term with multiple variables, and we saw how to find out. You just add up the exponents, and you can get the degree easily. So if you have a polynomial, basically it's the same as you did with the with example 2, with finding the degree of a polynomial, you find the degree of each term, find the degree of each term. So that's how you find the degree of a polynomial. Find the degree of each term and take the largest degree. Okay, so same thing here. Nothing's different. So we have this polynomial. We look at all the different variables that are involved. So according to our previous example and according to this definition, you're going to find the degree of each term. So the degree of this term, 2xy. Your variables x and y, so you add up the exponents. 1 plus 1 is 2. Here, my term is a negative 6x squared. There's only one variable, so the degree is 2. Here, the term is 5x cubed y squared. There are two variables. The exponents are 3 plus 2, which is 5. Here, this is a constant negative 6. The degree is 0. Here, 7x to the fifth, 7xy to the fifth, so the degree is 1 plus 5, which is 6. And then you look at all the degrees, 2, 2, 5, 0, 6. The largest is 6. So that's the degree of the polynomial. That's how simple it is. Okay, next one. So in this polynomial, the first term is 8x squared. There's only one variable. The degree is 2, the exponent. Here, negative 6xy. 1 plus 1 is 2. Here, 4y cubed. The degree is 3. There's just one variable. The largest of 2, 2, and 3 is 3. The degree of this polynomial is 3. Now, the idea of the degree will be important in college algebra when we talk about finding roots. So the degree of a polynomial kind of has a relationship with the number of roots, the number of solutions you're going to have. So that's where the degree is going to come in, is in the college algebra course. Okay, now this polynomial, again, there's just one term, so it's still a polynomial. Remember, polynomial is one or more finite terms. So the degree here will be 1 plus 3 plus 2, which is 6. Degree is 6. Okay, over here, this term, 6x cubed, there's only one variable. The degree is 3. Here, negative 2x squared, there's only one variable. The degree is 2, the exponent. Here, 7x to the first power, the degree is 1. Here, the constant term, the degree is 0. So the largest of these is 3. All right, let's get this one. Over here, the first term, negative 3x to the fourth y squared. 4 plus 2 is 6. The constant term, 6, the degree is 0. Negative 7xy squared. 1 plus 2 is 3. Positive 6x cubed y to the fifth. The degree is 3 plus 2, 5, which is 8. And here, the term positive 2xy squared, 1 plus 2 is 3. And the largest of these degrees is 8. All right, I want to mention one, though, and that's this. So let's write this as f. Suppose we had 5x squared y minus 2x cubed plus 6, let's do x cubed y plus 6x to the fourth minus 7y x. All right. Okay, the reason I'm doing that one is just to show you something, just in case you get that situation, you don't get a little confused. Here, this term 5x squared y, the degree 2 plus 1 is 3. Here, the degree of this term, a negative 2x cubed y, 3 plus 1 is 4. Here, 6x to the fourth, the degree is 4. And here, negative 7yx or 7xy, 1 plus 1 is 2. Notice, though, again, the degree of a polynomial is just the largest degree that you see. So I'm looking at 3, 4, 4, and 2. The largest of these numbers is the number 4. So the degree is 4. So it is possible for more than one term to have the same degree, just like we had here, 2, 2. So these two terms have the same degree, but again, you take the one that's the largest degree, so that'd be 6. Here, the largest is 4. It doesn't matter that it occurred more than once. All the degrees could have 4, the degree would still be 4. So all these terms could have degrees 4 met, and so the degree of this polynomial would be 4. And so that is how you find the degree of a term or the degree of a polynomial. Okay, so that's going to end part 2 of the lesson on Introduction to Polynomials, where we did discuss the degrees of terms and the degrees of polynomials.